Hey everyone, so you want to know how you're going to simplify an algebraic expression? Well, in this video, I'm going to explain to you how we can change a complex algebraic fraction or expression into a much simpler form. So we're going to be using factorization, using grouping, or maybe even a difference of squares to simplify our algebraic expression. This is the second part in a two-part tutorial, so you're going to watch the first part that explains algebraic expressions and what they are. Click on the link up here. My name is Peter. Let's get started. In this second part, we're going to look at simplifying algebraic expressions. But before we can start simplifying algebraic expressions, we need to understand clearly two concepts. Polynomials, what are they? And what is factoring polynomials? So generally speaking, polynomials are just algebraic expressions that contain one or more terms made up of variables with different exponents and numbers, or even sometimes a combination of variables and numbers. Factoring polynomials is a method that helps us to determine all the factors that are multiplied to get a given polynomials. These factors have to be the greatest factors that are multiplied to get a given polynomial. Let's dig deeper into what are polynomials, and we're going to look at how do polynomials look like according to the number of terms in that polynomial. So number one is a monomial. So monomial is simply if you just have one term. It could be m, just one variable, or you could have a variable and a number, 2x, or you could just have a number, -6. The next group of polynomials, according to the number, is binomials. This means that you have two terms. So you could have m squared -6. The third one is called trinomial. By now you should know that tri means 3, so you could have w squared minus 2xy minus or plus 5. So there are three terms here. Another way that we can classify polynomials is by the degree of the polynomial. Degree means the highest exponent that's in the polynomial. So the first group is constant, which is just a number. So if you see a number like a 5, those are constants. The next group is linear, so x plus 5. The x here has an exponent of 1. That's why it's called linear. The next group is called quadratic, so 2x squared plus x plus 5. So there are three terms, but the highest degree here is a 2, so quadratic. The last group is cubic, so let's say -x cubed plus 5. Even though there are two terms here, because the highest degree is a 3, this is an example of a cubic polynomial. So now that you know what polynomials are, the next thing is to look at the methods that we're going to use to factor these polynomials. There are three methods that I'm going to show you in this video. The first one is factoring a monomial. Second one, factoring using structure. The third one, factoring by grouping. Depending on where you went to school, your teachers might have called these methods a different name. In this video, this is how we're going to call them. So the first math problem we're going to look at when factoring a monomial is 8x squared minus 80x. So when I look at the two coefficients, 8 and -80, I notice that they have several common factors, 1, 2, 4, and 8. I'm only going to choose the number 8 because when you're factoring, you always choose the greatest common factor. So when you factor out 8, on the inside, the first term remains x squared, because when you divide by 8, you just remain with x squared. And then you continue with -80, divide by 8, and you have -10x. When I look inside the parentheses, I notice that x squared and x also have a common factor, which is x. So I'm going to factor out the x, put it right next to the 8, and then open parentheses, x squared, divide by x, I'm going to remain with just an x as the first term, and then -10x, divide by x, I'm going to remain with -10, close parentheses. When you check inside the parentheses, you notice that x minus 10, they don't have any more common factors, and you've finished that process. In the second problem, when you look at the coefficients 4 and 20, you notice that 4 and 20 have several common factors, 1, 2, and 4. So 4 is going to be the greatest common factor. So when you factor 4, you remain with na squared on the inside plus 20 divided by 4 is 5, so you're going to have 5 na b. So all I'm doing so far is I'm sort of factoring out bits and pieces. You can do this process with only one step, but I think if you're learning this technique for the first time, it's really important that you do this in several steps. So when you look at inside, you notice that both terms have n. So we're going to factor out the n and put it right next to the 4. N divided by n is 1, so that means a squared is going to remain in the first term. When you divide 5nab divided by n, the n goes away and you remain with 5ab. You examine inside the parentheses and you notice that there's a squared and there's an a in the second term. So we can factor out an a again. So for na parentheses, if you factor out an a from a squared, you remain with a. If you factor out the only a in 5ab, you remain with 5b. When you examine inside the parentheses, you notice that a and 5b don't have any more common factors, so we have finished that math problem. In the last one, we have a trinomial. It has 3 terms, so whatever we're going to factor out has to be common in all the 3 terms, not just 2 but all 3. So the common factor in all 3 of them is just an n. When you factor an n from n cubed, you remain with 10n squared. When you factor an n from negative 9n squared, you remain with negative 9n. And if you factor the only n here, you remain with plus 1. If you examine inside the parentheses, you notice that there are no more common factors and you finish the math problem. One of the most commonly used methods when you want to factor using structure is called a difference of squares. So a difference of squares looks like this. You have a squared, the first term squared, minus the second term squared. If you've got 2 terms squared, this polynomial is going to be equal to parentheses a plus b and then another parentheses a minus b. So in the first problem here we have 2x squared minus 18. There's really no way for us to write 18 squared or 2 squared, but if we factor the number 2 first, we're going to remain with x squared minus 9. Now in this form that's inside the parentheses, we can rewrite the 9 as a number squared, and that number is 3 squared. So now that we have 2 squares here, is simply going to be 2, the 2 that we factored out first, and in the first parentheses we have x plus 3, and in the second parentheses x minus 3. So this is the factored form of 2x squared minus 18. In the second math problem, we have 121y squared minus 36x squared. 121 and 36 can be written as squares, because y squared and x squared are already squared. So we're going to rewrite 121 as 11 squared, y squared minus 6 squared, x squared. And then what we'll do from here, we're going to take only the bases of our exponents. We're going to write 11y plus 6x, close the parentheses, 11y minus 6x. This is the factored form of the math problem. In this last math problem, we have a and b having exponents of 4, but we can use a really nice trick to change those 4s into squares. So the first thing that we're going to do is change 36 into 6 squared, and then a to the power of 4, we can write it this way: a squared inside parentheses squared. And then we're going to do the same thing with 25. So we're going to write 5 squared, and then b to the power of 4, it's going to be b squared squared. And then all we got to do now is take only the terms that are the bases of the exponents that are squared. So we're going to write 6a squared plus 5b squared, and then the other parentheses 6a squared minus 5b squared. All right, let's go ahead and look at factoring by grouping. And so here we got a problem 3x plus x squared minus 10. Before you start factoring any type of polynomial, you need to organize the terms according to the degree. So the first degree here should be 2, x squared should be the first term, 3x is second, and the constant should be last. Once you've done this, we need to find 2 numbers called the product and the sum. So the product is basically the product of the coefficient of x squared, 1, times the constant. 1 times negative 10 is negative 10, and the sum is just the coefficient of the middle term, which is positive 3. Using these two numbers, we need to think of two numbers that we can multiply to get -10, and the same two numbers we can add them to get +3. Those two numbers are +5 and -2. 5 times -2 is -10, 5 plus -2 is +3. These two numbers, we're going to use them to rewrite the polynomial. So instead of 3x, we're going to replace 3x with 5x, and the 5x comes from the +5 that we got here, minus 2x from the two numbers that we got here, and finally we just copy and paste the -10 from the original math problem. And then now this is where we're going to group the terms, because this method involves grouping terms. We're going to group the first two terms, x squared plus 5x, and then we'll group the second two terms, -2x minus 10. In the first two terms, the common factor is x, only x. So we're going to write x parentheses. Inside, we're going to have x plus 5. The next two terms, the common factor is -2. So factor -2, put a parentheses, x plus 5. It's really important at this step you notice that the two parentheses are exactly the same. Once you've confirmed that, you take the x that is in front of the first parentheses and the -2, and you put them inside the first parentheses, and then you only take one of the two parentheses that has x plus 5, and that will make up the other factor. Alright, here's a quick pro tip. Right before you start simplifying an algebraic expression, try to look for two important things. Number one, numbers or terms that can be easily simplified into squares. And number two, look for a common factor. These two things are sort of the building blocks of most algebraic expressions. Once you can identify them, then you can simplify your algebraic expression. Now that we know how to factor polynomials, we know what they are, let's look at how we'd use that knowledge to simplify a complex algebraic expression. This expression here is in the form of a fraction, x cubed plus 4x over 2x squared plus 8. And the first thing that we're going to do is just factor the numerator, and I see that x is common, so x, and then inside the parentheses we're going to have x squared plus 4. In the denominator, the common factor is a number. So the common factor of 2 and 8 is 2. So when you put 2 outside the parentheses, inside you're going to have x squared plus 4. Close the parentheses. Now you'll notice that the numerator and the denominator have a common factor, and we can actually cancel those two factors. When I use the word cancel, I mean that the two factors can divide each other, and because they're the same, they simplify to 1, and your final answer is x over 2. So let's take a look at a second complex algebraic expression that we need to simplify. In this case, we got a quadratic polynomial in the numerator and a linear polynomial in the denominator. So if you want to simplify, the first thing that you need to do is always factor the two polynomials. So we're going to factor the numerator, so t squared plus 10t plus 25. There is an identity for this particular polynomial, but I'm going to do this the long method. So we need a product. The product here is going to be just the coefficient here, 25, times the coefficient of t squared, which is 1, and that is 25. The sum is just the coefficient of the middle term. So the next thing is we need to figure out two numbers that if you multiply them, you get 25. If you add them, you get 10. Those two numbers are 5 and 5. Now in this case, because our coefficient of t squared is a 1, a really quick method is we just take the two numbers that we got, and those two numbers are going to form the two factors. So t plus 5 and the second parentheses t plus 5. This quick method only works if the coefficient of the squared term is a 1. So this is the numerator. We're going to factor the denominator. So we have 7 and 35. The common factor of 7 and 35 is 7. So we're going to write 7 parentheses t plus 5. Then the next thing is we notice in the numerator and in the denominator there are some common terms that can divide each other. So we just cancel those two terms, When they cancel, they just turn into a 1, and our final answer is going to be t plus 5 divided by 7.